record this. Right. Welcome everyone to week 4 of this USACO preparation class. So today we are going to first review the homework. I know the homework probably you feel that getting harder and harder, which is supposed to be. That we'll be getting some of those real USACO contest problem. They're getting a little harder. And then we are going to review briefly what we have learned in the data structure last week. Then we will continue to cover other data structures, those data structured in the C++ standard template libraries. So first, look at the homework. The first problem is just looking at distinct number for the list of n integers. So there are a lot of ways to do this. Right? So now since we have learned the time complexity, so as you solve a problem, you need to think about what's the time complexity of your solution, whether there is a more efficient way to solve the problem. Okay. So given this problem, right, the first thing that comes to mind is just read through this n integer and then check whether anyone is, whether there is any duplicate. And if it's a duplicate, then you ignore it. Okay. So you can, using, if you have not learned those data structure, which we are going to cover today, and there's 2 of the data structure which can help to solve this problem very efficiently. The first data structure is called set, right? A set is just like a mathematical concept. A set is only the unique element in a set. So if you use a set data structure, you just keep insert an element into the set. You don't need to care whether that element already in the set or not. It automatically handle the duplication for you. You only keep the distinct value in the set. So the first solution, so we would just use this set, std : set. This is a part of a standard template library. So for those of you, probably you have seen this, showed this in the past. This is like just one include header that will include everything that in the standard C++ library, whether it's IO string, vectors, or in the case that has set. If you just use this, you don't need to include anything else. So just a one include line should cover everything, all those in the standard C++ library to be able to cover all of them. And this is only true, I think, for the G++ compiler. So some of those compilers, they may not have this feature that include all those libraries in the C++ library. But in the competition, the good news is this is always supported. So whether it's in USACO or other competition, you just include this one line, then anything else, you don't need to include anything else, whether it's IO string or vector or the set or map, we're going to learn later on, or the others, stack and queued that we learned last week, or those, if you don't include it, you need to include each of those library. So, but if you just include this one line, then you don't need to worry about it. So once we define this set one data structure in a set of integer, right? So this angle bracket indicate the data type inside this set is an integer. So we just read this input as n number of integer, and then we just go through this loop, read through each of those integer, and then we just insert this value into the set, right? So this data structure automatically handle if there is any duplication. If a duplicate, you're going to throw it away. So we don't need to worry about that. So then at the end, we done reading all the data. We just check this set size, and that count the number of distinct value in this set. So this is probably the simplest solution and also the fastest solution. So if we know this is set data structure, so you can use this one. And the second solution, also very efficient, is using map. Map a data structure. Map is a mapping between two data, right? You can have the first integer and then the second integer. So map is like we're going to cover today. So you have a key and a value. So instead of like a normal array, right, you're using an index and then the value. So instead of the normal index, you use this as your key as your index and then the value. So we just using this one as to indicate this exists, right? So even if you have a duplicate, so map only allow distinct key value, right? You have a duplicate key, you put this key, you're just getting the same, right? We just set this to another value. If it already exists, it doesn't matter, right? This key, it doesn't create a new key, just set this key to the value to 1. And then we just count this map size that give us a distinct number of elements. So probably this set map, since you have not learned this tool data structure, I don't expect anyone to use this tool as a solution, right? So then probably the more natural solution, which is you have learned vector. So you can use a vector for this solution, right? You create a vector for this number n, right? So you read the first element, push back to this vector, then from the second element and onward, so we then need to only do from the second onward. So we want to stop at n minus 1, since we already read the first one and then push it to this vector. So we need to stop at n minus 1, right? Then from the second element, we read this second element. Then we check this second element whether already in the vector. If it's so, the one way to check is using this standard template function called find, right? Find, it gives you the beginning address. This vector is a begin address, and then this vector ending address, and the value that you want to search. So if it's you call this standard template function find, beginning address, ending address, the value that you want to search. If it will return the value somewhere from the beginning before the end, if you found it. If it's returned at the end, that means it doesn't exist in this vector. So if it equal to the end, that means it didn't find it. If it didn't find it, that means this new element we read it in, it doesn't exist in this vector yet. So we can push back, insert into this vector. Otherwise, we don't do anything, right? We just have this if condition. If it's not found, right, this equal to n, that means it's not in the vector. Then we insert to this vector. Otherwise, we don't do anything. Then when we are done, we just count this size function, right? We don't need to count the element, just call this function vector size. Also give a distinct value of the list of elements. So any question on this vectors solution? So probably you have learned the vectors, but I think I briefly mentioned this find function. If you don't know how to use it. So this is the next time trying to learn this using find. And then we're going to learn the find function for others, set and map. It has a built-in find method inside the set and map. Vector, unfortunately, they're not consistent. I wish they have been consistent. Like in a vector, it has the method inside the vector. Unfortunately, they have this as a global function that you pass in as a 3 argument as a find. And if you don't know how to use those data structure, right? You can just use a normal vector, right? So just an integer, you read this n, build this dynamic array x n, right? And then you build this or read this, each of them into this array. Then once you read it, then you have to go through each element, see how many of them are distinct, right? So then you need to write a function to count this array, how many of them are distinct. So you can write a function for given an array and the size, how many of them are distinct. So you can use a unique count to keep track, right? You go through this first loop, the outside loop. It goes through each element in the array. Then for each element, you need to get the second loop, right? So the first one that the element you want to compare any other element in the array. So we start from this I is outside loop, then the J is the inside loop. So you don't want to compare itself, you do I plus 1, so that it's the next element onward, right? So you start from I, you only need to compare forward every time, right? You don't need to compare backward. So that you do this forward comparison, then when you're done, you should getting all the distinct element. So you counting forward, starting the element you need to compare to J is I plus 1, and then J all the way to the end, right? This size is at the end. And since you set this J as I plus 1, or you can put this one inside, it doesn't matter. So probably it's better to put it inside this for loop. I see. The reason I didn't want to put it inside this for loop, since we need to get this J's value outside this for loop. We need to check when it's done, whether this J reach the end of this array, right? When it's reached the end, we have not found this. We're checking this I and J whether they are equal. If they are equal, that means it's duplicate. Then we break it. We don't need to do this comparison anymore. So that means that this we checking this I element is a duplicate with J element. All right. So we break. We don't need to count. Right. Then we go to the next I. Then we compare whether the I is there is a duplicate value with another J. So this is break. When we reach the end of this inside loop, which is here, when it reaches, that means this J equal to 5. That means there is no other duplicated value, so we count this unique. So that's why now we need to put this J outside this for loop. If you define the int J inside here, then you cannot get this J's value because it's outside this for loop, right? So that's something you need to be careful. So you need to make sure you define this J outside this for loop so that you can check the value of this J. So this is using two loops to count the distinct unique value, right? So this is probably not very efficient since we are just using a regular array, and this, but this is probably the most intuitive if you have not learned other data structure. If we look at the complexities on four solutions, right, the set and map, they are very efficient. Or we just read each element in a for loop, right? Read it, and then we are done. So just we do this and in the reading the and creating the set data structure, then we are done. We just call the size function. Similarly, map, right? And the vector, it is we do. If we look at the complexity for the vector solution, there's an outside loop, right? There is no way to, like, even the set and map, we have to read every element. So this or n on that's you cannot avoid it. But inside for each element, we are doing a search. The search algorithm, it is doing a binary search. So it's doing a search in. So we're going to learn those search algorithm. So search algorithm, the efficient search algorithm is log n. So that's something probably you need to remember. So it's the efficient search algorithm is log n. So then together is n log n for this vector solution. So we are doing a search inside and then outside a loop. But when we do the two loops in the function that we do it ourselves, right? We do, even though this is J is starting from I plus 1, is not the complete n. This size is n. It's a part of the, and it could be like half of n, for example, but n times half of n still n square, right? So that's still n square. So you can see in terms of efficiency, those four solutions, so definitely set and map are most efficient. But map is creating a redundant variable, like you use two variables like to it. So memory-wise is getting some extra memory with a set, just one variable, right? So set is time most efficient and memory most efficient, and then map is same as set time memory efficient. Time efficient, but memory is not as efficient as a set. Okay, any question on this first problem? Second problem, Friday the 13th, right? So it is asking you to count every month, the 13th, and then starting from 1900, January 1st to 1900 to whatever the input and number of years, then count how many of those 13th day, what's the day of week that fall into. Right. So there are a lot of computer, it's a built-in function to do this for you, but it asks you not to use some of those the built-in function want you to calculate this using some basic structure, right? So the first thing, right, since it every month other than February, right, isn't fixed every year. It's February in the non-leap year is 28 number of days, and then it's a leap year is 29, and give you the logic to calculate whether a year is a leap year or not. So the first thing you need to write a function to handle whether for a given year a value, you need to calculate that year, whether it is a leap year or not, right? That will be the first thing to handle the leap year. And then you just need to, once you handle that, then you need to, for each year, go through each month, January, February, and go through each of month 13th, like, and then figure out whether which day of week that 13th day is, whether it's which day of week it is. So the first thing, calculate the leap year, right? So you can define a Boolean function, right? Boolean is a leap year for the given year variable. So the first thing, whether it is divisible by 4, right? If it's not divisible by 4, then you return as a false. If it's not divisible by 4, automatically it is a non-leap year. But if it's divisible by 4, then you check whether it is a century year or not. If a century year, then it has to be divisible by 400. If it's divisible by 400, then it's a leap year. Otherwise, it is a non-leap year. And if it's not a century year and it's divisible by 4, then it is a leap year, right? So you have 3 if condition, then it's just if else, if else. Right. Then once you have that leap year, then you just handle the reading, the input, right? So the first thing, reading how many years, right? Reading this n as a number of years, and you're building a weekday. So the day of week with array of 7 elements, you initialize everything to be 0, right? Just count each of those 30, how many day of week it falls into. And then you also build an array of number of days each month for this 12 months per year. We start from those non-leap year, right? 31 January 28 and February 31 March, etc. So you keep track this. Then the only thing that will be modified is the February 28. If it is a leap year, you need to change this to 29, and everything else remain the same. And you start with 1900, right? And the month you start with 0. Then the problem they told you that January 1st, 1900 is a Monday. Then the first thing that we need to loop is January 13, right? January 13, 1900, what day of week it is. And we plus 12 days, right? From January 1st, 1900, we plus 12 days to getting the 13th, January 13. And we do modulo 7, right? So that will give more. So any of those days, we do modulo 7 to figure out what day of week it is, right? And this is indexed by, I think Saturday is 0, and Sunday is 1, Monday is 2, etc., right? Which is the problem they define. So 2 is a Monday, so it's starting that January 1st plus 12 days. So this is 0, this is a 14. So this is also, this should be a 0. That means it is a Saturday on the first 13, right? So that's the starting value. Then we go through the loop, right? Probably easier rather than go to the, say in the PowerPoint, let's look at the code. So we go through this number of years first, right? This n is a number of year. Then the first thing is call our is a leap year function. For this year is starting that, right? Then we starting this, then we increment. We stop until it's n number of year, right? We increment at the end because we already giving starting as 1900. Right? So we could, instead of doing I, we could do it like this, right? So we can just say year is 1900. You could do it like this, and then just year less than 1900 plus n, and then just do year plus. Right? If you don't want to use it, then you can get rid of this, right? But that's another way to do it. If you want to use a less number of a variable, then you don't need to use I. Okay, so then you can get rid of this. Right. So you check the year whether it is a leap year. If it's a leap year, you set this days, number of days for that month. That one is February, set it to 29. Otherwise, you set it to 28, right? And then you go through this 12 months. This M is for each month, right? And the index, we already calculate. This is the day of week for the 13th. So this is the first 13th, right? We calculate that day of week. So we set this a weekday, set this just to increment one. And then we set the next month with this is 13 plus this current month, the number of days, then do a modulo 7. Should be the next month's 13th day of week. Right? Then we go through the loop in here, then we set. When it's, it doesn't matter when this is in December, they go to the next year's month, it doesn't matter, right? So this when it's go to the next year, it's still, this logic still hold, right? So we're adding the December number of days in December, that will go to January's index. Then we go to this year's loop. Then when we are done, this weekday array should have the answer that is output. We just output this date of week. Right. So any question on this is Friday the 13th? Okay, so probably the next problem, broken necklace. This is a little harder problem. The first need to understand what this problem was trying to ask you, right? So from a necklace, since it's a loop, it is, but it has the starting value. You treat it as an array. You read it as an array. It has a starting value, but you just need to be aware of that. This when it's beginning, then it will connecting to the end, right? You can go around that. So what is asking you to like whether when it's a break at any point, right? This is an end, so it can be anywhere. When it's a break, one of those play, and then you can get the bees same color from either end, from the beginning or from the end. You can take them out, and if they are white, and then consecutive white or with another color, you can treat the white as same as another color, but you cannot mix red and blue together, right? So that's the only constraint. You cannot mix red and blue together. When you take out the bees, if they are all red, you can keep getting the next one, or if it's white, you can keep going until you reach black. Or if you start a blue, if you start with a blue, then you can keep going with until you reach red, and then you need to stop. Right. So the first thing is read this data in, right? The first read the input. That shouldn't be too difficult, just two number. Read the number of bees, and then this string to put them into a string, right? And then you, in terms of the logic, right, you need to think about where could be the break point. So you set this a break point from could be 0 all the way to n-1, right? That's only the n position. Then for each of those break point, how many same color bees that I can get from either end, right? So you can, once from the break point, you can look at the one that you counting, you're getting the forward versus the backward, or you can call it either forward, backward, or left and right. It doesn't matter, right? It's just two direction. So how many bees with the same color I can get from the breakpoint forward, and how many bees with same color I can get going backward. And then you just add this forward and the backward together to get the maximum number of bees. Then that's for each given breakpoint, right? You then keep tracking the max bees. Then you go through this loop, and once you go through this n number of breakpoint, then you should get the maximum number of bees value. But there's some complication, right? Whether there are some bees that are white, right, which it can be treated as either red or blue. So you need to keep track. What's my current bees color, and what's my previous bees color when you go forward. So you start with the first bees color, then you get the next one. The next one you check whether they are different. You only need to check when the next bees color is different from the previous one. Then you check whether previous one is white. If it is white, that means the current bee is a non-white. Then I set my previous bee's value to the current, right? So because you don't want to keep that white. You want to set the previous to non-white. Then you keep going until you reach a different one that is a non-white. Right now you reach this logic is different again. Is my current is white. If it is white, then you keep going. If it's not white, then you stop. Right, that's the logic. Then you encounter, start from one non-white B, you reach another non-white B that is a different color. Then you stop. And similar logic when you're doing backward, right? You start from B, keep track of what's the previous color and the current color. You keep going until the current B's color is different from the previous one, and until those previous and then current, they are two different color, two non-white color. You stop. But then there is, since we are doing a loop, right? When you going forward, you could reach it at the beginning, right? When you reach all the way to n, you reach all the way to n, you should set this to 0 so that you can go to from the beginning of the bees, right? You need to set this to 0. But you just make sure that you don't get into a loop. That means when you doing this traversion, you shouldn't do more than n number of bees. You start from I, you should stop at n plus I plus n, right? You don't want to get into a loop. So they could have a situation, the bee, they're all same color. If you do this logic, you don't have the stop, you set this to, and then you can get into an infinite loop, right? So that's the first thing. You need to set this to 0, but also make sure that you only traverse n number of bees. If it doesn't stop based on logic, this should stop as well. And then when you count backward also, right? You count backward, you reach the beginning when it's a negative, right? When it's a negative, then you need to set it to n. So that is starting from n, then count backward. So when you reach it, this n is from 0, then you minus 1, then it was negative, then you need to set it to n, to the last b. Then you come backward. And then similarly, you need to keep track. But this, instead of stop at n number b, since whatever it is, we have a traverse in this count forward, right? We have this count forward increment. So it should be n minus this count forward so that we don't duplicate those count forward in the count backward. So if we say already get 10 of those B with the same color with this forward counting, then our backward counting should be n minus 10, right? We shouldn't duplicate counting those already getting out from using the forward method. So this is also very important. And then when we are done, this is stop, then we just add this two together. Okay, so that's probably a little more complicated logic. So you need to have a two variable to keep track previous and current, as well keep track the number of loop that you have done, as well as reset when it's reaching the end of that, since it's using a necklace, right? So you can go from the end, go to the beginning. So we first do the reading the input, right? So and reading the color of the into this string S. Then we use some temporary variable like the I and J, as well as a two number counting forward and counting backward to keep how many bees that we can count forward, how many bees we can count backward. And then we also use a two-character variable. What's the current bees? What's the current previous bees color? And then we have this max bees, which is to be the sum of these two. Right? And then we go through for each. This I is the break point, right? This I is the break point. So when this I, so for any breakpoint, the minimum we can get is the first bees, right? So this is always true. So as long as we find a bee, then we can start with 1. We getting this j as I, right? That's the first bee. Then we set the previous and current the same color as this j, this color. Then we do the count forward. So we make sure that this count forward is less than n. While this is less than n, then we increment this j. And if a j reach the end, we reset it to 0. Since we want to go through a loop, go to the beginning. And that's why this while it is important so that we don't get to the infinite loop, since we set this is j when we reach the end of this array, set it to 0, right? Then we get the j is our current b. We get the color of this current b. Then we compare whether this current versus the previous. When they are different, right, they're not equal, then we check this previous one. It is a white or not. If it's white, then it's okay, right? We can just, that means that this is different. That means that this current is a non-white, right? That means that we want to set this previous one to a non-white B. And else, they are different. This previous one is also non-white. But if this current could be a white, right? If a current is a non-white, then we need to break. That means we need to stop here. So this current is a non-white. Previous is also a non-white, and they are also different. That means we need to stop. Otherwise, we just keep going. We can get the B, they are the same color. We just count this, then we go through the loop. So that's the only condition when there's two previous one and the current, they are both non-white, right? We stop. So any question on this logic? Okay, so this where so this portion is for counting forward, right? So then when it stop, this break will break out of this while loop, right? Then we exit this while loop, and this CNT underscore forward should have the number of bees that we can remove with the same color, either same color or with some white color, right? Then the counting backward, right? Well, first of all, we also we can check whether we have gone through all the bees, right? If this count forward equal to n, that means we already get all the bees. We don't need to do anything. We don't need to do come backward. So we set the max b into n, then we break this loop, break outside this outside loop as well. Right? If it's not satisfied, then we keep going. This is for counting backward. So counting backward, we start from, since I is the breakpoint, that the previous one, so I minus 1 is the B's before this breakpoint. We count from the I minus 1 and then counting backward. And then if J is negative, then we set to the end of the B, n minus 1, right? So we reach the end of the B counting backward. We also come back, but we always start from 1, right? And then we set both of this current and the previous to the color of this J, which is J is I minus 1. Then we do the same logic, right? Except now instead of this while loop, we need to set it to n minus count forward. Those already being count forward, the remaining number of B's, make sure that we are not exceeding this remaining number B. And then so count forward, we use J plus plus. Now count backward, we use J minus minus. Right? And when it's equal to -1, then we set it to n minus 1. So this is the inside loop, right? We also have this. This is the beginning, just to make sure that is not, this I could be a 0, right? I is starting to be a 0, then -1, then we need to set it m minus 1. And this is inside the loop. This J can also be a -1. So -1, then we set it to the last element of this array. Now we have the J, then we just get the current color of this B, and then same logic, whether this current different from previous. Then previous, if it's a white, then we set the previous to this current, which should be a non-white. And if current is a non-white, then we stop. That means both. This is a non-white, right? This is already else. That means the previous is non-white and then current also non-white. Then we stop. Otherwise, we keep going. We come backward. Then at the end of this loop, we do for this breakpoint I, we getting the forward and backward, sum them together. See what's the previous value of max B. We start with 0, right? And then this max B is set into this sum. When it's that means this max B, we checking every breakpoint. This will be the maximum value of a B that we can get. Then we are done with all possible breakpoint. Then we are done outside this loop. So any question on this problem? So we put this together. And so this outside loop for the n number of possible breakpoint I. Okay? You go through each of the breakpoint and then use each of the loop inside this breakpoint. You calculate the possible B, which is count forward and count backward, sum of them, and you compare this max B, whether they are greater than that. If greater, then you set the max B to that value. Right. So this is in the outside loop. You keep track that. Then inside loop, you just calculate this, count forward, and then count backward. Okay, let's take a 10-minute break. We'll come back to learn the new data structure. All right. Hope everyone is back. So let's quickly go over what we have learned last week in terms of the data structure. We have learned arrays, different type of arrays. Array can have a static array, traditional way with just int and an array giving the number. Then you can also have a standard template array with std : array. Then this way, then you can use some of those standard template associated function to access this array. So that's a trade-off. This is a traditional way. It is more probably memory efficient, but then you using this std array with some wrapper, then you can have some built-in function to access the array. Like for example, you can check the size and then as well as some of those functions associated with a standard templates array. Then for the dynamic array, you can use this standard template as a dynamic array, or you can also use this standard with this int and then just with the size of the array. So this is after C++ 11. This is allowed, used to not allow a variable as the size of the array. And probably we use the most is the vector as a dynamic array. And think we like this vectors dynamic array is, in this USACO competition probably more often as a dynamic array. This is more of the data structure of a choice for the dynamic array. Then for stack is a special type of data structure with just a one way in and one way out. And then queue is a special one with you enter from the end and then you get the element out from the front. So it's a FIFO one, versus stack is the LIFO, the last in the first out. And then string is an array of a character. So you can think of a string as a dynamic array of a character. And the size of the array is not fixed. So you can pretty much you define a string of variable which can handle any length of characters. Okay. Then today there are a lot of other data structure. I try to go through all of them as much as possible. Hopefully we can cover so those important one, pairs, tuple, set, and map. And then within the set, there are different type of set. We probably don't need to go through them. Let's just go through just in terms of high level, right? In the C++ standard template library, the data structure, they put all the data structure in a container, inside the container, then they classify them whether those data structure are sequential, right? They are linear, sequential, they're one next to each other. So those are the vector list and then EQ and arrays. Those are the sequence in the sequence. Then those in a more adapter, they're not necessarily store those elements in a sequential way, not in a sequence like queue and stack. Those are not in that sequence. And there is also priority queue, which we not going to cover in this course. Probably we don't use this priority queue that much. Then today we're going to learn this associative data structure set map, right, as well as a multi-set and multi-map. And then on the set and map, they are ordered. So they are you can put in the sorted order. Then there's unordered, the associated map. So the unordered set, unordered map. So we are going to learn set and map. I think those are the probably most important data structure in terms of algorithm. You already seen that in the first problem that we want to solve in the last week's homework, that using the set and map can solve a distinctive value very efficiently. Okay, what is a pair in this STL data structure? Right, a pair data structure just put the two variable. Typically, they are the same data type, or could be a different data type. I put the different data type, pair them together. Right? Why do you need to do that? Right, you want to put the two variable together, oftentimes so that you can associate them together. Okay, it could be there's a first name, there's a last name. It could be a person's name and a person's a day of birth, a person's name and the gender of the person, etc. Right? You want to associate with an ID type of variable with some attribute, or it could be something they are just next to each other, right? So you pair two variables together in this pair name. And you can access the first variable with a pair dot first. So the first and the second are the two methods you can use to access those two elements inside a pair, right? So you do two type. So they can be the same type or different type. And then you can put two variables using a make pair together to make pair, or you can using this braces to put two value as a make pair put in, right? You see this braces almost you can use the braces to assign any value, a list of value to any data structure, right? This can be assigned to an array, can be assigned to a pair, then later on you can see can be assigned to a set, right? So this a braces type of the value structure is almost universal in C++ since C++11. And then we mentioned that it's a pair dot first and dot second to get the first value and the second value, right? So those are the first and second are the methods. So let's look at some example. Let's look at Visual Studio Code. I have this example. Pairs. Okay. So we said you define the pair. Well, first of all, you need to have this include function. Right? I mentioned this. You could have just this one include that include everything. If you don't have this, then you need to include here, right? So and as well as we use the cout, then you need to do the include IO string, right? So versus we may use other data structure. Trying to see, yeah, that's the only two we use. Okay, So probably we can just use this two instead of this one, or you can from now on, like let's for everyone just getting to a habit, just have this include it, right? You can have a space in between. It doesn't matter whether it's pound include with a space or without space. It's slash stdc plus dot h and then the angle bracket. So and have this two line in your C++ code as a standard going forward, right? So we don't need to worry about what are the standard library we need to include. Then this is a pair, right? This is then the more of the personal preference, all right? You since we using this using name space std, we could just call it pair, or we could call std : prefix, right? So probably this is actually better in adding those using the : prefix so that we won't get any confusion. Where is this pair defined? If you have also a variable, say called this variable as a pair, right? Then this may get duplicated, right? So then you have this prefix, and there is no issue with this duplicated name. All right. So this is how you define a pair, right? This is two variable in this pair is one is integer, one is a character. So you can assign the value, the dot first. This is also a variable. Is assign the variable to the value, and dot second, the second variable, and then you can output the value. That's one way to assign the value of a pair. Another way to use this make a pair function. Make pair is a standard template function. Okay? So you make this return a pair. So you make this a pair, one variable, return this make pair function, get the value to this pair one, right? So this is a character and a integer. So character and an integer. So you could use a make pair, and you can also, right, after you output the value with a dot first, a dot second, right? And then you can also two pairs, you can swap their values. There is a pair dot swap, and you can swap their values. So you can use swap. And this is probably is the easiest way to assign a pair value, right? You define this a pair, P, right, two integer. So I just use this braces. This braces put the two value into this pair. So you see this is much easier versus you have to, like the first method using the dot first, dot second, and the second method using a make pair versus this just using the braces. It's easier. Then you are getting the value inside this pair. Then you can check the value dot first, dot second. And this dot first, dot second, actually they are not a method. So you don't need to put in this parenthesis, right? You don't need to put in the parenthesis when it's a function, right? When you do this, this is a variable. And like this is another example, we can put in a string and integer. So it could be a person's name and score. In a test score, we can put them into a pair. Right? And once you made this a pair, you could put this pair in a vector. So you now you can do the combination of data structure. Right? You could have a vector of pairs, right? So we do this vector, right? Inside the vector, the data structure is a pair. And what's this pair? It is a string and an integer. Right. So inside this vector, it is this pair. So this is student score, right? This would just have a list of each student's their name and their score. So we can put the braces, right? Each of them inside the braces, then it is a pair. We push back. So this is a vector push back. We call this a vector as a function push back, right? This is a method of parentheses. Inside the parentheses is a braces. It's a pair of braces. Then that is a pair. So we just keep push back to this vector's value. And when we are done, then we can print it out what's in this vector of pairs, right? So we can use a for this arrange loop. You have seen this, right? So this each element is complicated. We don't need to know what's the data structure. So you can use this auto. So you use auto, then it's for each element, it automatically assign the type of this element by getting one score from this student scores vector. And then we get this first and the second, which is a pair. So any question on this pair example? Okay. So the next data structure is expanding a pair. You can only pair two variables, right? So why do we limit two variables, right? So that's where the expanding instead of just two, then it could be any number of variables put them together. That's called tuple. Tuple. Or you can think of that way. A pair is just a special case of a tuple. Right? Tuple, you can have as many number of variables together, and they could all have a different type, right? And pair is just a special case of tuple with two variable, right? Tuple you can have but you do need to know how many number of value in this tuple when you define it, because you need to define each variable's type in this tuple. So similar to the pair, instead of say you call the make pair function, now you call this make underscore tuple. Then you do the parenthesis, how many value is in the tuple. And then instead of dot first, dot second, right? We cannot do the dot first, dot second anymore since it has more. It doesn't have the first, the second, the third, etc. This is just too many. Instead, you get this get angle bracket and I is 0, 1, 2. So 0 is the first element, and then 1 is the second element in the tuple, and 2 that will be the third element, right? You start the index from 0 all the way to whatever that number of element in that tuple. You use this very strange type of function. So it is a function, right? It is a parenthesis, get, then the I. You cannot put a variable I in there. It has to be a constant. It has to be a value, right? If you say put I instead of I variable value to something and then do this, no, you cannot do that. You can only take a constant. Excuse me. So this is how you use this get angle, whatever it is, that index, get a value from a tuple. So let's look at an example. So look at tuples example. So similarly, we just use this with standard C++ header file, or we have to include this tuple, right? And since we are also using vector, and you include vector and IO string for the cout as well, right? So the tuple similar to pair, right? You said, so probably don't want to have a space, even though it doesn't matter. So just commonly when you define or data type, just have the angle bracket for the template without space to the data structure. So this tuple, we define that has three variables. First one is a character, second one integer, and then third one is a float, right? So then you define this, declare this, right? This right now is empty. Now we assign the value. We can use this make tuple to assign the value. So since this is three variables, so we make tuple need to assign three values to this tuple. So the first one, make sure that when you call this make tuple, each data type has to be corresponding to whatever the data type you define in the tuple. First one is the character. We have to give a character value. Second is an integer, so we need to give an integer value. Third is a float, then we give a float value. Then this tuple has been initialized, assigned a value. Then we can use this get function, get, right, 0, angle 0, get the first element of the tuple. So parenthesis is the tuple's variable. And then the get 1 is the second element. And then the get second 2 is the third element. And you can also use this, which is kind of strange, right? So this get, it is a function, can be return value, can also be a function that you can put on the left-hand side in the assignment to change the value as well. So you can set the value using this get, change the value. So this is a lot of it counterintuitive. If we think about normal function, you won't be able to call the function and assign the value, right? This versus this one is it is an this function is smart enough, able to find the memory of this variable and then copy, change this value to that memory address. Okay, and we change this value. We can also print it to verify it is different. And then instead of make tuple or using this get to set value, using this braces is the most easiest way to set the value of any data type, right? This is tuple, we can use braces, and earlier we said pair, we can use braces. If it's a set, we can use braces. So just remember, using braces is probably the easiest way to assign value to almost any C++ data structure. Okay. And so we assign this, then we can use get. And similar to the vector of pairs, right, we can create a vector of a tuple, right? So you define this vector, and then inside the vector, each element is a tuple. So this tuple has 3 variables: string, integer, and character. So in this example, so we do the student name, and then the test score in the 100 scale, and then the score, the GPA in alphabet. Right? So we can make this as a tuple, those 3 variables. And we can write in this, you see this vector, right? You use parenthesis of a parenthesis. The first parenthesis is for the vector. The second parenthesis is for the tuple. And then each comma, it is each tuple, each vector's element, right? So there are 1, 2, 3, 4. There are 4 elements of this vector. And then each element is a tuple. Right? So you can have parentheses of parentheses. Okay. Oh, I'm sorry, it's not a parentheses, it's a braces, right? It's a braces, braces. So we can also use a pushback. This the parentheses is a function, right? Parentheses for the function, and then we use braces as the assignment. Braces is the value for this pair, or for this tuple, this no pair. And when we are done building this vector of tuple, we can use this for range to print it. And you could define the type, or you can just do an auto, right? So you could do this, or you have to keep track the type. Then using auto is easier. So you automatically at runtime figure out what's the data type of each element of the vector. So use this auto variable to do for each is much easier. Okay, any question on tuple? Okay, we are going to learn the set next, right? So you already see this is set in the homework. Right? Set, it is it's a non-sequential, so it's not like an array type is a setting. So it is known as associated, right? So it is each element is in a set is unique. So it is also stored in a sorted order. And internally, a set it is stored in a tree structure, in a binary tree structure, which we probably will learn the tree and the graph later on, right? So it's sorted. It's like when you insert a value to a set, you compare from the root node, then going to the left and the right, see whether it is greater than the node. Then if it's greater than, put it on the right, less than, put it on the left. Right? If it's the same, then you just set replace or don't do anything, the value, right? So that's how it can get the distinct value and also in the sorted order. By default, it is doing the ascending order. So then when you get the set, it is sorted in an ascending order. If you want to have a descending order, then you need to set a special parameter when you define the set. We'll give it see an example. But in terms of the syntax, that's the std : set, and then this angle bracket. The T is the data type, whether it's integer or the character, flow, or double, or string, whatever. Or it could be another complex data type. Right? So then you give your set a variable name. So this is an example. We define this set A as a set of character, right? So it's a character, and once you declare this variable, you can use this insert method to insert the value to this set, right? Insert it, or you can use this um, braces to set the value, right? You see this one, it has a duplicate value, right? This is 8 and 8, and then this is a 9, there's a 9. So we can use this example to check whether it will remove the duplicate value, right? So this we initialize with a 2 duplicate value with 7 element, and then we can use this size to tell us what so the actual size of this set, as well as we can use this for range, this the loop, right? Each element, we can use this auto, right, to get each element from the set, bring each element, see what is the element in that, right? So let's run this in the code, right? So this set is very important. So make sure that you feel very comfortable to use a set, and you will use a set very often in the USACO context, since this is the data structure that will make the list of elements unique and sorted. Right? So you define this, you use insert, can use the auto, and when you're doing the auto, you see this a funny ampersand. So this is more for memory efficient. So instead of getting each variable, just getting the elements address. So this ampersand is getting the address. For this character set, it doesn't matter. It's just if for the complex one, the address of it is smaller versus the actual copy will be bigger. When you don't use the ampersand, then you're getting the defined a copy. So it will, in terms of memory efficiency, isn't not. But you don't need for now. You don't need to worry whether I need to use an ampersand or not. Excuse me. And so, like this example, it doesn't matter. We're just using the. You can use it just I, or if we use an ampersand. You're putting the ampersand anywhere in front of auto or with a space or without a space in front of I, it doesn't matter. And for now, you don't need to worry about the ampersand. And that's how you print it. Then this is the example we set this with and with the 2 duplicate values. So let's see this one. Need to get the terminal. the terminal here, we can run this code. Want to go to the terminal, type in the wrong window. So it's mess up. Okay. Let's clear this terminal window. So just to I already let's recompile this. Right. Right. So remember, this is the example I want to show. We initialize this set with 7 elements. 2 of them are duplicated, right? So it's that the number element is actually only 4. Okay. So since is so 9, 8, 7, and 12. So only 4 of them are unique. There are so 3 of them, actually 3 of them, 7, 8, and 9, 3 of them are duplicated. So you see this set is 7, 8, 9, and 12. So we go through the loop, it's in the ascending order, even though we add in a more random order, right? The element inside this set is not only unique, but also in the sorted ascending order. Okay, so how do we get a descending order set? So if you want to have a set that is descending, then you put this greater, and then this angle bracket, what's this data type, just to do the comparison. So this greater will be in the descending order. So this S3, we declare that is an integer of descending set. Then we insert those value. We can just so we keep inserting more, right? So this is 50 inserting twice. Is either should only get 1. Then we print this out, and there is a multiple way to iterate to a set. You can use the auto. Then for each element, that's definitely easiest way, right? This is the easiest way. So probably this is something you need to remember. And another way to iterate it through is to declare this iterate function or variable rather. So you starting from the begin to the end. So this is a pointer. So it's a pointer pointing to the begin of this step, and then go to the end, and then you do an increment. And then the asterisk of this pointer getting the value. So this probably instead of, since this is iterator data type, you don't have to do that. You can do a for, like just we use that trick using auto. So we can do an iterator equal to this as we begin, right? And then we do the iter is not equal to the end. Then we just increment. So we can do this as well, right? This will be similar to this is identical to this set code, but you don't have to remember this iterator is this data type. You can just use auto, right? Use begin and end. So this is another way to going through the set, each element of set, or you use this for each element. And this is, we said it is a descending, so you can see the descending, this S3, right? So this is a descending order. So 60, 60, 50 is all the way to 10, right? So this is a descending order. Just need to add a greater in the second argument. The first argument is the data type, then greater, and then the angle, bracket, whatever the data type of the first here, the definition. And what else was a set? And then set, there is other function other than begin and to get the first and the last, but also actually n is not the last. N is the one the ending is not right. You need when you need to stop it need to be less than that, right? You need to less than that. You cannot equal to. And you can use a erase function, right? Erase those elements from which range. You can give a beginning to or whatever the end. Okay, now with the set, you have a find function, right? Rather than the vector, which it doesn't have a find function, set has a find function. So you for this set, you pull this find, and then whatever the value you need to find, then it will return the pointer between begin and less than n if I can find. If I cannot find, so this is find is very important. If you cannot find it, then that means it's reaching the end. Actually, do I have don't have an example defined? Thing I have in the slide. Right. So when we check our value, whether it is in a set or not, right? So you can use this find function, and find can either take a constant or take a variable, right? And you use this auto, so you will return a pointer to the data type. So you have to be careful, right? So if you don't know the data type, just say auto. And if this find return not equal to n, that means we found an element has the same value as this find value. Otherwise, if it's equal to this n, that means it doesn't exist. Right. So this find function is very useful. So you need to learn in a set to have this find function. And this find function, since this set is a sorted order and it's a binary tree, can find the value very efficiently. Okay. We have a few minutes left. I want to go over the map quickly. So we said the map is another important data structure. Right? Map, it is similar to pair, right? If you see there is two variables, but it is putting one as a key, another as a value. So that's you probably can accomplish the similar objective using a pair. A map, it is just make it more efficient. It has a lot of built-in function, and internally it is using a hash map. The key, take the key value, creating a hash map, so that when it's trying to search for the key of the element, it can find it in an O1 type, right? It doesn't need to do any search. So map is a very special data structure. So you have similar, those methods we see, begin, end, and size, and empty. All of those methods has in the other data structure. Right? And so it's an example, right? We define the map. So this map, so between the string and an integer, this is map one, then we give. So the first variable, it is a key, right? You put the key's value in this square bracket. So you treat them like an index, right? This is the key value. This is the key, this is the value. The key and this is the value. And for those of you have learned Python, right? This is identical to the dictionary data structure in Python. So map is in C++ identical to the dictionary. So you can have a key and a value. Right? So in this example, we can have a student name, right? Student name and then the score in this map. And then we can go to each of the element of this map, and then get the first and the second, or you can get the, if you look through the key, then you can just say key the value, then the key the value. So other data structure in the STL, including multi-set and unordered set and unordered map, and as well as the linked list. So those are probably in USACO, we don't use those data structure much. And you can just look at the textbook or just Google it, look at the W3 school, look at those data structure yourself if you're interested in them. But pair, tuple, set, and map, those are very important. And for those common data structure, there are some of those common methods that we can use, like in terms of you already seen how to use the iterator and the range to go through the element, right? You can use the begin and end to get the first element and then the last element. Remember, the last element is the ending. It's a need to be before that if you reach this end, it is already empty, or that is the one that before it is actually the last element. So when you use a find function to go through, then it return this end. That means it didn't find anything. It's empty. And we, like even in the vector has the begin and end as well. And then for vector, they are not automatically sorted, unlike set or map, right? So you can call this a global function, this the standard template global function called sort. You can call this a sort, right? Just put the beginning address and then the end, and then without return anything, it automatically sort the element in the ascending order. If you want to do the sort descending order, you call this a reverse. It's same beginning end, but call reverse. It's sorted in descending order. Or you want to sort them randomly, you call this a random underscore shuffle. So that will make this vector randomly arranged, right? So it begin, end, and sort reverse. So those are the functions that you work with vector a lot when you need to sort a vector. So we already went through this. And then the range, we said there are two ways you can use iterator, right? This auto iterator begin, end, and then just iterate. But then remember this iterator, it is a pointer. You use an asterisk of the pointer to get a value, right? And okay, that's all with all the data structure in C++. Any questions for today's class? All right, I'm going to post the homework.